Cold, KJ? I tell you, KJ, I'll tell you when it's cold. When you start seeing me wear my black wool coat, then it's cold. But until then, it's not cold yet. I think we still have a few more weeks before it gets cold. Don't worry. Okay. Next now. Very good. How do you say it? You're saying it right. How do you say it?
Yeah.
No.
Go on. You're right. Go on.
Arithmetic progression.
That's it, yeah. So, arithmetic progression now. So let's have a look at a very special type of sequence here. This sequence here. Or maybe something like this one here. Yeah, something like that. They both have something in common. What's that? There's a similar rule here. What's happening? You're adding 2, yeah. So here you're adding the same number. So when this happens, we call the sequence arithmetic. So a sequence with a constant difference between terms is called arithmetic progression, or just AP, I'll say. So here the difference is 2 each time, and here the difference is 2, as an example, yeah? A sequence with a constant difference between terms is called arithmetic progression. It's called an arithmetic progression. Can you see?
Between the terms.
A sequence with a constant difference between terms is called, yeah, AP. Yep. Can I scroll down?
Yeah. Yep.
Okay. So, a little bit of notation. We'll call A the first term and D the difference. Sorry, two M's here. Common difference. Yeah. So for example, if I call the first term, guys listen, come on. If I call the first term A, then the next term will be A plus D. And the next one will be A plus D plus D. And the next one will be A plus 3D, etc. So this actually gives us my first formula. The nth term would be A plus n minus 1D. So we have 2 formulas for this lesson. This is the first one. I'll do the second one in a few minutes after we have a look at some examples using this formula. Okay. Can I scroll down? Yes?
Thank you.
Yes? Yeah? Okay. Right, so let's start with a simple example first. Find A and D in this sequence. 2, -2, -6, dot, dot, dot. Okay, to find the A, that's easy. The A is always the first term, so that's 2. The D is what you add here. So in this case we have to add 4, and this case here, no, sorry, not add 4, -4. Well, add -4. So -4 and -4. If you want to know how to find the -4, it's easy. You take any number and minus its neighbour. So we can see here it's -6 minus -2. Or you could take -2 and minus its neighbour. -2, -2. In both cases you get -4. -4 is what you add to this to make it become -2. -4 is what you add to this to make it become -6. So D is -4 here. Okay, write that down and we'll have a look at another example. Find the nth term in -9, -14, -19. Yeah, yeah. Okay, do you have this? We'll do it there. So, what is the nth term? The first term is -9, the second term is -14, and the third term is -19. So we can definitely see that A is -9, and what would D be here? -5. So the nth term, by using the formula, is A plus n minus 1D, yeah, which is -9 plus n minus 1 minus 5. Now we need to clean this a little bit. This is -9 minus 5n plus 5. Yeah, which is, what's that, -4 minus 5n. And this is the answer. Let's check that the answer works. If I put n equals 1, then do I get -9? I do.
Yeah.
So that's correct. If I put n equals 2, -4 minus 10 is -14, correct? If I put n equals 3, I get -4 minus 15, which is correct. So this is right then. So this is for the nth term. Okay, write this example down. Yeah, got that? Can I scroll down now? Yeah? Okay, let's have a look at another example now. So next example. This time I want to know how many terms are in each of the following. So, or, well, in this case, how many terms are in this sequence? 7 minus 1 minus 9 dot 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 minus 137. So here we don't know how many terms there are. There's obviously at least 4, but there's got to be much more than 4. We want to know how many. So does anyone have any ideas on how we could work out how many terms we have? Any ideas on what we could do? Yeah? You got there first, sorry.
Calculate A and D.
A and B, A and D.
A and D. A is 7.
Yeah.
And D is and 6.
Yeah. Next.
And put the A and D into the formula.
Yes.
And you have calculated and
Very good. Yeah, that's it. So the idea here, like you said, you get A, you get D, and you use this formula. UN equals minus 137, and you're trying to find N, because you want to know how many you have. So we can say A plus N minus 1 D equals minus 137. So that means minus 8 times N minus 1 equals minus 144. So that means N minus 1 equals, what's that, 18. So N is 19. So there are 19 terms in this sequence. Yeah. Okay, can I scroll down? Yeah. Okay, so if I want to find A and D, how many terms do I need minimum? No, only need 2. I only need 2 as a minimum to find A and D. Yeah, I just need 2. That's enough. So for example, if I have a sequence and I tell you the 8th term is minus 46 and the 19th term is minus 112, that's enough to find the A and the D. Because what you can say is that A plus 18D, that equals minus 112, because that's the formula for U19, the 19th term. And the formula for the 8th term is A plus 7D. And you realize, oh, of course it's enough, because I have 2 equations with 2 unknowns. So I can solve this to get 11D equals, now what's that, 12 and 54, 68, is it? No. 54, 66, with a minus. Yeah, so this means D equals minus 6. You can take that and put it back in to say here. So you get A minus 42 equals minus 46. So A equals minus 4, yeah. And you've now found A and D from only knowing 2 terms in the sequence. Okay, write this example down. So, and then we'll have a look at the next formula. Got this, Bruce? Yeah.
I'm sorry,
Alright, missed steps.
Yeah.
Which step? Oh, the previous one.
Sorry.
No problem. I'll zoom out. And how about here?
Thank you.
More? Okay.
Yeah, I'm a little bit.
No problem, no problem. Is this enough now?
Yeah.
Yep, okay. Got this? Need a bit more time, Sarah? Yep. Yeah. Okay, we'll continue then. So far we've talked about an AP sequence, which is UN equals A plus N minus 1D. We haven't talked about an AP series, which is when we want to add up the terms. How do we do that? Well, let's have a look. So for example, an example might be something like 2 plus 4 plus 6 plus 8 all the way up to whatever, 100 as an example. So let's see how we can calculate that. Just a little bit of notation. Sn is what we use to represent the total, the sum. Let's try and find a formula for this. Okay. Can I scroll down? Not yet? Oh no. Just let me know when you're ready. Okay. Yes?
Yeah.
No? No, I'm giving you too much time. I'm afraid you'll have to catch it from someone. Okay, so let's have a look here. Sn is when we want to add the first n terms together. So the first term is A. The next term we want to add is A plus D. Can you see what's happening here? Then the next one is A plus 2D. We want to add all these together, finishing. What will be the last term here? I see you're thinking, should I say minus 1 or not? Yes, you should. Correct. Now that's obviously a very big formula. Is there some way to simplify it? There is a way to simplify it. I wonder if anybody knows or remembers the way to simplify this formula. There's a trick to simplifying this. Nobody remembers this from high school?
No.
Oh, that's the answer, but how to get there? Yeah, but that's the answer, how to get there. Okay, I'll tell you. So the trick here is what you do is you write the sequence out, you write the series out again, but you write it... Yeah, what's the word, Jerry?
I mean, you calculate another...
Yeah. Yeah. And what's the other sequence you create?
I forgot. Maybe Sn minus 1.
Oh. No. Nice try. I thought you had it, but you didn't have it. Nice try. Yeah.
I think calculate the square of epsilon.
Nah, that's too difficult. Nah. Maybe it'll work, but not what I was thinking. I have a nicer way. What you do is you write the series out again, but you write it out backwards. So you have A plus n minus 1 D, and then you continue all the way down. So let me just write that a bit neater. A plus n minus 1D plus A plus n minus 2D, and you continue all the way back to the start. A plus D plus A. And then what you do is you add them together. So you get 2Sn. Now, something interesting happens here. Let's look at adding these two together first. So you have A plus ND minus D. Is that right? A plus ND minus D. Yeah. Which is 2A plus n minus 1D. And let's look at the next two. These ones. That's A plus D plus A plus ND minus 2D. That'll be 2A plus n minus 1D. The same. In fact, all of them will be the same. So each time you get 2A plus n minus 1D. And then you get the same again. And again. So because you have the same thing many, many times, in fact, how many times do you get this? N times. You can just say this is 2A plus n minus 1D multiplied by n. Then you can divide by 2, and you end up with the formula Sn is n over 2, 2A plus n minus 1D. And this is what you were thinking of a moment ago when you were remembering something from high school. Okay. Got that? Continue? Yeah. So, why is this formula useful? It's useful because you can take a very big problem and just make it one small problem. Let's have a look at some examples. So, my first example is I want you to calculate S40, which will be 8 plus 11 plus 14, and keep going until you get to 125. Add all of these numbers together. Well, if you really wanted to, you could add them all together on your calculator. How many numbers would you be adding together? 40. This would take a while. Or you can use the formula. Let's see. A equals 8. D equals 3 and n equals 40. So, our formula for the sum of the first 40 numbers is n over 2, 2a plus n minus 1 times d. Let's see, that's 20 times 16 plus 40, 80, 157? No, what am I saying? 4, 8, 12, 117, isn't it? 20 times 133, which is 2660. So that was much quicker to do than adding all 40 numbers together. The answer would have been 2,660. Okay, let's have a look at some more examples now. Can I scroll down? Yep. Okay. No? Take a minute. You got it? Are you sure?
Yeah.
Okay. Next one. Find the sum up to the nth term. So this time I don't tell you where to stop, just at the nth term. So it's kind of the same as the last one. A equals 5, D equals 8, and N is N for this one. Yeah. Okay, so Sn equals N over 2, 2A plus N minus 1 D. That is N over 2, 10 plus 8N minus 8. N over 2, 2 plus 8N. That is N times 1 plus 4N, which finally is 4N squared plus N. Now, I just want to show that this formula works. If I just add the first term, what's my total? 5. Put 1 into this formula and what do I get? 5. Good. Now, if I add the first 2 together, I get 18. If I put 2 into this formula, 16, 18 I get. One more. If I add the first 3 terms together, well, I get 18 and 21. What's that? 39, isn't it? Now, if I put 3 into this, I get 36 plus 3. I also get 39. So we can see that this does match with this. 3 squared is 9 times 4 is 36 plus 3, 39. Yeah. Yeah. So it does work. Okay, write this one down. We'll have a look at a harder one now. Okay. Continue. Now, just like earlier, it's enough if I tell you 2 sums to get the A and the D. So, for example, suppose I told you the sum of the first 12 numbers is 630. And I'll also tell you that the 27th number, for example, is 237. So by telling you a sum and a term, that's enough to find the A and the D. Just like what you did earlier. So here you can say A plus 26D equals 237. And here you can say N over 2, 2A plus N minus 1 D should equal 630. So here you can say 2A plus 11D equals 15? Oh, 150? 150, yeah. 105? Yes. 105, of course. Thank you. 105. But you realize, oh, this is just like what we did earlier. There's no difference. So what I do here, I think I'll just multiply this by 2. Yeah? So now I get 2a plus 52d equals 474. And I also have 2a plus 11d equals 105. Can I solve this? Yeah. What's that? 41d equals 370. No. What is it? And does 41 go into 369? Make me happy and tell me it does. 9 times? Good. And I can put the 9 back into this one to get the D. Let's see. A equals 237 minus 26 times 9. So what do we get for the A? 3. So I have my A and I have my D now. Okay. Let's do another one like this, but a little bit harder now. Okay. Continue? Yes? Okay. The sequence minus 4 minus 5x, 9 minus 7x, 9 minus 3x is arithmetic. Guys, come on. Find x. So what I've done here is I've given you 3 terms in a sequence, but I haven't told you what they are exactly. X is missing. What I have told you though is the sequence is arithmetic, and that's actually enough to find the x here. What could I do to help find the x here? The difference should be the same, exactly. So the difference between the first and the second, which is D, that should be the same as the difference between the second and the third, which is D. So we can say 9 minus 7x minus 4 minus 5x, that's D. Yeah, and that should equal the other one, which is 9 minus 3x minus 9 minus 7x. That's also equal to D, and of course they're the same. So now we can say 9 minus 7x plus 4 plus 5x equals 9 minus 3x minus 9 plus 7x. Okay, take all the x's to the left. Minus 7x plus 5x plus 3x minus 7x equals 9 minus 9 minus 9 minus 4. Okay, that is a, what the heck was that? That was a plus 3 or minus 3? Plus 3. Right, 5 plus 3 is 8. 8 minus 7 is 1. 1 minus 7 again, minus 6. Cancel, cancel, minus 13. Now I didn't make these have nice answers. X equals 13 over 6. That's the answer for X then. Okay, write this one down now. Okay, another example. One more example now after this. Yeah? Yep, okay. Calculate this, we'll say. -8, -6, -4, up to 178. Alright, well let's see what happens. What's the A here? -8. And the D? +2. And the N? We don't actually know, do we? Because I didn't tell you how many terms I have. So how can I find the N? Well, we've seen how to do that already today. So let's find the N first. Yeah. A plus N minus 1D should equal 178 then. So we get N minus 1 times 2 should equal 186. N minus 1 should equal 93. So N should equal 94. Now I can work out the sum. It's N over 2a plus N minus 1d. 45 would make 90, so 47 then makes that one. Minus 16 plus 186. So that's 170 times 47. I've reached my limit now. 47 times 170. 7,990. Yeah. Zoom out.
The numbers down. Yeah.
Got that written down?
Yeah.
Yeah. Okay. Let's scroll down. So let me give you some to try. So from number 1 DE, 2 DE, 3 DE, 4 DE, 5 CD, make it different. 6 EF, 7 BC, and 9 B. Now I know there's a lot here, but the thing is, this is an important exam question because I think nearly 100% of exams have a question in section B on this topic, either this topic or the next topic, so it's very important for the exam, very important. And they're not too long to do, so if you can try these now. Close.
Yeah.
push it. Should we sleep? No, nearly asleep.
Very
Ah. Fahad, we're finished. When I say we're finished, take your books back out. Attendance, now let's see. Alvin?
Yeah.
Yeah. Amelia? Tony?
Yeah.
Where's Tony? There's Tony. Clement?
Yeah.
Jonathan? Dana? There's Dana. Dylan? Drew? Honica? Yash? Eric?
Yeah.
There's Eric. Andy?
Not here.
Where's Andy?
Not here.
Yeah, where?
I don't know.
Alright. Dennis?
Yeah.
Sarah?
Yeah.
Fahad? Okay, science and engineering now. Science and engineering. Okay, let's see. Yeah. Come on. Here we go, okay. Andrew?
Yes.
There you are. Bruce?
Yeah.
Monica? Chrissy? Jerry?
Yeah.
KJ? Brian? Lee?
Yeah.
Victoria? Sean? Sammy? Okay, we'll finish there. So try your best to get those finished, and they're important for the exam.